All right, let's start our Test 5 review, which is the final module for our course. Confidence intervals, you'll notice the very first question says omit. That is misplaced on this test. I don't know what happened, but you don't have to do that one. Well, I shouldn't say you don't have to do that one. It'll give you the answer. So if you can manage to click the answer that it tells you to click, you'll get that right. You could still theoretically miss it if you can't do that, but hopefully that won't happen. Anyway, number 2. We're given confidence levels, we're given standard deviation, and we're given the sample size. We're asked to find the margin of error for the given values. The margin of error is how far we're going to allow ourselves to go on on either side of the mean to build the confidence interval that we want. And the formula for margin of error is error equal to z, and I have a c down here because the z changes based on the confidence level. Remember, we've calculated these in the last video, and I wrote them down here. So we'll be using one of these z's depending on what our confidence level is. That's what that z is, and that's multiplied times the standard deviation divided by the square root of the sample size. And that'll give us our margin of error. That's the amount we'll allow ourselves to go on either side of the mean. So all you have to do is plug these numbers in. And on this test, because if I can find it here, ran short of time one semester, and so when you print the PDF off, you get this really sloppy handwritten page that I did that shows you each problem worked out. So I'm going to cheat so I don't have to do all this stuff by hand. The calculator's a little awkward to use on my phone since I'm doing video on my phone. But all the problems are worked out here. But I'm going to work a couple of each kind just so you can see what we need to do. But you already have them worked out on here. You can reference that. So anyway, for number 2, the error is the z associated with the confidence interval. Well, the problem says they want the 99% confidence interval. So we look at that and we see it's 2.58 that we calculated in the last video. So the error equals 2.58 times the standard deviation, 10.3, divided by the square root of 50. So it really just becomes a calculator problem. And you can put this in one long calculator string here, 2.58 times 10.3 divided by square root of 50. And we end up getting, what do we end up getting here? 3.75. So that's the margin of error we would allow ourselves to meet these requirements. That's the margin of error we would have on either side of our sample mean. I'll do one more like this, number 3, because these are really straightforward. The error equals, now this is a 98% confidence interval for number 3. 98% is 2.33, which means we're allowed to go out 2.33 standard deviations on either side of the mean. Each standard deviation is 0.78. And the square root of the sample size, the square root of 150. We get, for that one, 0.15. So that is our margin of error for number 3. Let me move down to number 5. Now we're going to actually build some of these, not just calculate the margin of error, but carry it all the way through. Number 5. A group of 49 randomly selected students has a mean age of 22 points. This is 5. A mean of 22.4 years. Population standard deviation of 3.8. So this is the sample mean, 22.4. Population standard deviation, and we'll talk about that a little more in the next video. The population standard deviation of 3.8. They want a 98% confidence interval. Now, we talked about what our margin of error is. Let me write out the whole formula for the confidence interval. We want the true population mean to be between the sample mean plus the standard error and the sample mean minus the standard error. So we're given a sample mean. We're just going to find the standard, the margin of error that we found up here, just like we did here, and we're going to add and subtract it from that mean, and that's going to give us our interval. And the choices on the test are not written. Sometimes in some books you'll see them written this way. Ours are going to be written in interval notation, just in parentheses with the lower end and the upper end. So that's the way I'll write them on here. So for our lower end, let's say we got to do our margin of error first. 98% confidence interval means we use 2.33 for our z. 2.33 times the standard deviation, 3.8, divided by the square root of the sample size. $49. I lost track of it there for a second. Let's see what we get. And then we're going to take the x bar plus that number and the x bar minus that number. And that gives us 21.1 on the low end and 23.7 on the high end. So the way they're going to write it here is 21.1, 23.7. So you calculate the standard error, which I don't have calculated out, but I have the final answer here. You calculate the standard error, not standard error, margin of error out, and then you're going to add and subtract it from the sample mean that you're given, which is that number. So 22.4 minus whatever this E comes out to, and I got that turned out to be 21.1, and then 22.4 plus that number, 23.7. So this is our margin of error. So this is saying we can be 98% confident that the true population mean for this group of data, which is students that have the age of the mean age of a student. We're 98% that the mean age of a student in this group falls between 21.1 years and 23.7 years. So that's what we're claiming here by doing this. Let me do another one of these, and then next video we'll switch to a different problem. Let's see, here's number 8 here. 42 8th graders. That is our sample size, N, 42. They watch television, 19.6. That is our sample mean. And the standard deviation, population standard deviation is 5.8. And we want a confidence interval of 98% again. So our error is going to be the z that goes along with the 98% confidence interval, which I have right here, 2.33, times standard deviation 5.8 divided by the square root of the sample size, right there. So we have our x bar minus the error and our x bar plus the error. Let me write that out. The x bar we know, it's 19.6, so it would be 19.6 plus whatever that error comes out to, and 19.6 minus whatever that error comes out to. And that's going to be $17.5 and 21.7. And this is written, I kind of got a reverse order here, but the way they are going to write them is with the small number first and then the large number. So we're saying that we are 98% sure that the true mean falls between 17.5, is it hours? Yes, hours per week, and 21.7 hours per week. And that's our confidence interval. All right, next video we'll do some using a t-test, when there's a slight difference, different chart, but the process is the same.